All right, Ex1C is getting you to revise what was LCMs and what is HCFs. So let's fill this in. It says here, find the lowest common multiple, which stands for LCM, or LCM stands for lowest common multiple, of 6 and 8. Remember, multiple kind of reminds you of multiplication. Multiplication means you make it larger. Okay, so if you make it larger, it's another way of saying means groups of or multiplication. Fill that in. So if you know it's multiplication, really it's asking you to fill in your 6 times tables and your 8 times tables. So here when they say find the lowest common multiple of 6 and 8, you start off by writing the 6 times tables and the 8 times tables. So let's go. I've got 6, 12. Let's go with Hamza. What's the next number? 18. Good. You just add on an extra 6 because 6 times tables means you add on 6 each time. So 6 plus 6 is 12. 12 plus 6 is 18. Next number, 18 plus 6 gives you what, Charlotte? 24. Very good. Next number, let's go with Aqualia. 24 plus 6. 30. Very good. And then Nikki, 30 plus 6. 36. Very good. Next one, let's go with... What is? Anyone else? Ollie. What's the next number? 42. Very good. So these are your 6 times tables, and you can keep going, but we want to check if there's a lowest common multiple. So let's now do the 8 times tables. Next one. 8, 16, 24. What is the next number? Let's go with Gypsy. 32. Good. Let's go with the next one. So adding on an extra 8. What is 32 plus 8, Fitzroy? 40. Very good. And then 40 plus an extra 8 gives you what? Let's go with Josh. 48. Good. 48 plus an extra 8. So that's now 8 times 7. 8 times 7 is what, Jacob? 56. And then finally, 8 times 8, which is Xavier?
64.
Very good. So these are the better your times tables, the quicker you can figure out your LCMs. So if you didn't know, you can write it out like this. Might take a bit longer, but you will get the answer. So here you got the multiples. These are called multiples. They can keep going because it grows. That's what multiplication is. Yeah, it grows, it gets larger and larger. Now we're looking for the lowest common multiple, meaning out of all those 2 lists there, which 2 numbers, or which numbers are they in common, but the lowest number. So let's highlight what's common here. Okay, so I've got 24. They both have a 24. So they both have 24 in common. They both have... Well, actually, if I continued on a bit more, you would have seen the next one. There would have been 48 as well. That would have been in common as well. But we want the lowest common multiple. So clearly the lowest common multiple must be?
24.
24, very good. So that's how you would do lowest common multiple. If you haven't done it before, it's about knowing your times tables. Now, on the back of your maths exercise books, usually they have the times tables. So you can look at that and compare. Yeah, or you can list it out the way I've just organized for you. But that's what LCM is. What's the difference between LCM and HCF? Well, that's different now. HCF stands for highest common factor. Now, factor is not a multiple. Factor is actually the opposite of multiple, which is the division component. So what you ask yourself is when you're saying, what is the factor of 6 and 8? What you're asking is, what numbers can I divide that fits well into 6 and 8? Now, let's think about the numbers. 6. What numbers, so this means division, what numbers can 6 divide with no remainders? Give me one number. Hands up if you know. 6 divide what? 3. 6 divide 3 equals 2, so 3 is a factor. What's another one? 2. We've got 2. 6 divided by 2 is 3 as well, so 2 is a factor. What else is a factor? 1 is a factor. 6 divided by 1 gives you 6, so that's a factor. One last one. There's another one. 6. Very good. And what you find is that if you know your times tables, you can figure it out. 3 times 2 gives you 6, and 1 times 6 gives you 6. It should have that sort of pattern. There's a pairing. And so these are your factors. See how factors cannot grow like multiples? Multiples can go infinitely large. Factors, on the other hand, do not. Factors are just the division components. So let's do the same now. 8. Give me a factor of 8. What number can I divide? Let's go with Willow. 2. 2 is a factor. Give me another one. Let's go with Adele. 4. 8 divided by 4 is 2. So 2 times 4 is also a pair. Give me another factor. Can I please have... Let's go with... Who knows? Yichen. Factor of 8. What am I missing? Give me a number that you can divide into 8. 4 is there already? 8 is what we're missing. Good. 8 divided by 8 is 1. Okay, and then, what is the last number? There's another number here. Anyone know? 1. Very good. So 1, 2, 4, and 8. Again, notice the pattern. They have pairings. So the better your multiplication tables, the better you can find the factors and pairings. See the difference? One goes on infinitely. One is limited. Okay, so factors is generally harder because they don't know their times tables, and then you have to figure out what multiplies or what divides. This one's easier if you know your times tables, or you can add them. You can figure out multiples easier. So, what's the question? The question is asking for highest common factor. So what's common about the two? They both have a 1. They both have a 1. They both have a 2. And that's about it. So those are what's common, but we want the highest common factor. So the highest common must then be 2. Very good. Okay, so this is what you'll be doing in exercise 1C. That's what LCMs and HCF is. It's nice to know because in the next exercise, I'll teach you a short way to do for bigger numbers. So how do you find the lowest common multiple and highest common factor? You need to know what these are and also one extra information, which is on the next page. But for now, let's fill out some things that we currently may or may not know. What's this symbol here mean? Can I please, or hands up if you know. Ollie, how is it? Fitzroy. 6 squared. Okay, so 6 squared. What does 6 squared actually mean though? Josh. Very good. 6 times itself. So that's times 6. Okay, not 6 times 2. A lot of the students think this is 6 times 2. It's not. Okay, 6 times 2 is 2 times 6. That's literally right there. But 6 squared means 6 times 6. If you wrote 6 cubed, what does that mean? Very good. It becomes 6 times 6 times 6. And you can see there are 3 of them there. So the power or the indices tells you the number of times you're going to multiply itself. So 6 squared, what does that equal to? Can I please have... Let's go with Charlie. 6 times 6. 36. Very good. So when they say, what is 6 squared? The answer is 36. Now, what's the opposite of squaring? Because if you can add, the opposite of adding is subtracting. If you can times, the opposite of timesing is dividing. So if you can square, what's the opposite of squaring? Square root. Okay, so square root. Now, what does square root look like? Square root looks like this. So, when we say square root of 36, that's what that means there. It means, can you think of a number that times itself to give you 36? That's what it means. So you write square root of 36. It's asking what number times itself gives you 36? What number? 6. Very good. We literally just did it. 6 times 6 is 36. So when they say, what is root of 36? The answer is 6. Let's test your understanding now. What's root of 81? Root of 81 means something times itself gives you 81. What's that number? 9. 9 times 9 gives you 81. So hence, the better your times tables, the easier it is for this part. So 9 times 9 is 81. So the root of 81 is 9. This is your correct answer. This is the method. This is the thinking. Okay, so how do you know what root of 81 is? And you just need to know your squared times tables. Let's try another one. I'm going to make it up on the side here. Fill this in. What is the root of 16? Can I please have, even I've chosen over here, yes, ignore. 4, because 4 times 4 gives you 16. So the root of 16 is 4. Let's try another one. What's root of 9? Can I please have, let's go with Willem. 3, because 3 times 3 gives you 9. Okay, so you got to think backwards. Instead of squaring, you're doing square roots. It's the other way. Yeah? What's another one? Let's go with 49. What's root of 49? Can I please have... I feel like I've chosen everyone here. Let's go back to Gypsy. 7, because 7 times 7 is 49. Does that make sense? So you got squaring and you got square rooting. Square rooting's harder because you have to know your times tables really well. Yeah? Next one, and the best way to do this is using your times tables charts. Just look for the 3 times 3, 4 times 4, 5 times 5, 6 times 6. Just look on the diagonal and you can find your squared numbers. Okay? Now we already said about squaring. Cubing, this is called cubing. To read it, we say 2 cubed. 2 cubed means what? Can I please... Yes, Fitzroy.
2 times 2 times 2.
Beautiful. And what is 2 times 2 times 2? Eknor. 8. Very good. 2 times 2 is 4. And then 4 times 2 is 8. So when they say, what is 2 cubed? It's not 2 times 3. It's 2 times 2 times 2, which gives you the answer of 8. Now let's see if you know this. So you knew that squaring has square root. If we have cubed, there has to be the opposite of that. What's the opposite of cubing? What's the opposite of cubing? Cube root. Very good. And this is what it looks like. Cube root looks like a square root, except you have a little 3 at the front. So the little 3 that sits just on top of that little hook, that is called cube rooting. So when we say cube root, it just means what number times itself 3 times to get you the result. So for example, if I said, what is cube root of, let's go with 27. I'm asking, what number times itself 3 times to get you 27? Very good. 3 times 3 is 9, and then 9 times 3 again is 27. So the answer is 3. So when we say, what is cube root of 27? The answer is 3. Okay, so this language here is cube root. So let's test your understanding now. Let's try this one. Cube root of 64. What number times itself 3 times to give you 64? Yes, Zara? 4. Very good. It's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Now, it's not expected that everyone knows their cube numbers. It might help if you write on your sheet of paper and use a calculator first to list it. So list out 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, 7 cube, 8 cube, 9 cube, 10 cube, and right up to that point, that's enough. Okay, so most of the numbers that you work with is between 1 cube to 10 cube. Use your calculator just to have a note of it, so that way you can answer the questions when you see them. Okay? All right. Let's try these ones now. I'm going to give you, let's give you 2 minutes. It's 2:18. 2 minutes to answer that last bottom bit there. Here we go. I'm going to pause the video. Let's pick. Hamza, what is 7 squared equal to? Not 14, because 7 squared is not 7 times 2. It is 7 times 7, which is?
49.
29. So that common mistake there, just be careful. 7 squared does not mean 7 times 2. 7 times 2 is 14, but 7 squared means 7 times 7. So going to 7 times 7, go to your times tables, it's 49. Oh, whoops. Sorry, team. This is what I was writing. So 7 squared is not 7 times 2. That's what a lot of students think. 7 squared means 7 times 7. So 7 times itself twice, and 7 times 7 is 49. Next one. Root of 36 means something times itself gives you 36. What is that number? Can I please have? Let's go, Jacob. 6 is the correct answer. Give yourselves a tick if you got that right. Next one. 3 cubed. 3 cubed is not 9, not 3 times 3. It is what, Zara? 27. Very good, because it means 3 times 3 times 3. 27. Give yourselves a tick if you got that right. And the last one, D. Cube root of 1,000 is what, Xavier? Oh, okay. Something times itself 3 times to get you 1,000. Anyone know? Hands up. 10. 10 times 10 is 100, and then 100 times 10 again gives you 1,000. So cube root of 1,000 is 10. Cube root of 1,000 is 10. Give yourselves a tick if you got that correct. Otherwise, learn it from just experience. But like I said, if you list out the cubed table over here, use a calculator, list them out, it'll be easier to answer those questions. Turn over the next page, and here's your final notes for today. Like I said, I've given you all the prime number chart under 100. So all the ones that are shaded, those are your prime numbers. What are prime numbers? Here are your two definitions, or two key components. Number one, a prime number has to be divisible by only 1, okay? And it is divisible by the number itself. Question. What do you think natural numbers mean? Anyone know? Hands up if you know what a natural number is. Belinda. That's true. So it doesn't go in decimal, so it has to be whole numbers. And there's also one more thing. Natural numbers. This is like the first thing that most civilizations started off with in terms of mathematics. It's whole numbers and positive. Otherwise, it's also known as counting numbers. You started off in mathematics by learning how to count. And that's what they used to do. They had to count, resources and bookkeeping. The first thing they had to do was count. So different civilizations back in the days would have counted differently. There's binary systems. Ours is in units of 10. So we've got 10 digits. Some countries or some tribes back then did not have 10 digits. They may have 3. So they counted 1, 2, 3. And then once you hit 3, they then had a different system to count. 4, 5. So it's like binary, etc. Okay. But I don't want to confuse you with that. So we work in 10-digit system, which is called metric or decimal. So counting is called natural numbers. When they say natural numbers, they just mean counting numbers. Okay. So what are prime numbers? It has to be divisible by 1 and the number by itself. Now, prime numbers must be a natural number greater than 1. Now, this is a big misconception that a lot of people, even adults, still don't know. Prime 1 is not a prime number. Why? Why isn't it a prime based on the definition so far?
Because it gets used in every single other number, like you can divide it.
That's right. It can be divided into every other number. And remember, it said it can only be divisible by itself and by only 1. Okay? So, because it can be divided into other numbers, it is not a prime number. It is technically a composite number. So, that's why in your chart, notice the number 1 is not circled. Okay? So, prime numbers are numbers like 2. You can only can be divided by 1 and 2. So, in itself, so it has 2 there. 3 can be 1 and 3. 5 is 1 and 5. Why can't it be 4? Because if you write down the factors, you can have 1, 2, and 4. 4 divided by 2 works, 4 divided by 4 works, and 4 divided by 1 also works as well. That is why this is called a composite number. It's made of multiple numbers, so composite or prime. So every other number that you see there that is not shaded, that's a composite number. Every other number that is shaded, it is a prime number. Okay? We'll need to know this definition because, and this chart will be useful for tomorrow's lesson on prime factor trees. Okay, but that's it for today's lesson. I'm pretty sure on Teams now, if you log in, you should be able to see your readiness task in assignments. Remember, when you finish, I want you to go compass, go to your learning task, and update your reflection. Yep. 1C will be for tomorrow. You have half a session to do 1C tomorrow. All right, I'm going to stop the video.